Hello everyone, I am Alok Kumar and I welcome you today to the lecture on basic trigonometry. So let me now share my screen with you all and start the lecture. Okay, so the first thing that one has to learn in basic trigonometry are some trig identities. Means that in it so happens that behind every problem in IIT JEE Advanced or Mains, there is some kind of identity. So it is good to revise some very important of them. So let me start by writing important ones like sine of a1 plus a2 plus an. We have done for sine a plus b, that people remembered, but this is often forgotten. So sine of a1 plus a2 plus an, there are n angles. So that equals cos of a1 times cos of a2 times cos of an, and s1 minus s3 plus s5, and so on, alternate positive negative. And similarly cos of a1 plus a2 plus an, there are n elements here in the argument, and that equals again cos of a1 times cos of a2 times cos of a1, and you have got now 1 minus s2 plus s4, and so on, alternately positive negative, where s1 is sigma of tan a1, that is tan a1 plus tan a2 and so on, taken one at a time. S2 is sigma tan a1 tan a2. So this is called taken two at a time, that is tan a1 tan a2 plus tan a2 tan a3 and all those numbers. And similarly s3 is sigma tan a1 tan a2 tan a3, that is taken 3 at a time. And in general s of k is sigma tan a1 tan a2 tan ak, that is product of these tangents taken k at a time. That's entirely routine. Now in particular, if a plus b plus c is 180 degree, in particular if a plus b plus c is 180 degree, that is they are the angles of a triangle, then you get sine of a plus b plus c, that equals cos a cos b cos c, and times we can expand, and as you saw earlier I wrote s1 minus s3, so I can write in full that tan a plus tan b plus tan c minus tan a tan b tan c, that is sine a plus b plus c. If we come to cos of a plus b plus c, then that is cos a cos b cos c, and here you will have 1 minus, because it was 1 minus s2, as I can scroll back, 1 minus s2, so this is 1 minus now s2, so you will get 1 minus tan a tan b minus tan b tan c minus tan c tan a, provided all these numbers are meaningful, means that you are not putting something like 90 or other thing, so they must be all be defined. And you can of course tan a tan b I can write as sin a sin b cos a cos b, so I can write entirely in terms of cos a cos b cos c, or sin a sin b sin c. Now especially when this is triangle, then this will become a plus b plus c 180, so this will give you negative 1 is cos a cos b cos c, and 1 minus tan a tan b minus tan b tan c minus tan c tan a. So this gives the identity which is useful often. So if you write negative 1 upon cos a cos b cos c will become sec a sec b sec c. So you will have that tan a tan b plus tan b times tan c plus tan c times tan a. These numbers, they will become 1 plus sec a sec b sec c. So that kind of thing is useful, this kind of identity, provided you know these values a b and c. Another important identity is product of cos and angles in gp. So cos theta cos 2 theta cos 4 theta last term cos 2 to the power n minus 1 theta. So these all arguments, theta, 2 theta, 4 theta, and this, they are in GP. So that is 1, 2, 2 square, 2 to the power n minus 1. So there are n terms. And this equals sine of 2 to the power n theta, means just next term into 2, this one, and over same 2 to the power n, so 2 to the power n, and sine of theta, provided of course sine theta is not 0. Anyway, whenever we write such things, then we are of course assuming tacitly that things are all defined, well behaved, and so suitable restrictions will be imposed by the problem setters. So this is one example, cos theta, cos 2 theta. This often finds use. If you forget it anytime, then just see that for n equal to 1, the left side is cos theta, and right also should give you cos theta. So you can fix some error, that is sine 2 theta upon 2 sine theta, and that equals cos theta. So it means you can fix your error if at all you forget or you confuse between whether this will be 2 to the power n or 2 to the power n plus 1 or anything. Some more identities which are useful in telescopic summation. When you do telescopic summation in trig series, we have done in algebra. When you do this, then some of the useful ones are cot theta minus tan theta, that equals 2 cot 2 theta. In fact, derivation goes like this, that cot theta minus tan theta is 1 upon tan theta minus tan theta. So 1 minus tan square theta over tan theta. Multiply both numerator and denominator by 2. So that gives you twice tan theta, and 2 1 minus tan square theta. And that equals 2 upon, this is 2 tan theta over 1 minus tan square theta. That is 2 over tan 2 theta. And that gives you twice of cot 2 theta. In fact, we derive this way, but to use in the problem, we use in this form. Good form is tan theta is cot theta minus 2 cot 2 theta. This is tan theta, cot theta minus 2 cot 2 theta. So somebody can ask you tan theta plus 2 tan 2 theta. So somebody can ask you the problem tan theta plus 2 tan 2 theta plus 4 tan 4 theta, and so on. And you should be able to use this to find the result. Another result is similar looking. Cot theta over 2 minus cot theta is cosec theta, and it is useful if you have to find, say, 1 upon sine theta, 1 upon sine 2 theta, 1 upon sine 4 theta, all in GP. You have to find this series. Then in this summation, the useful is this one, the one we have written just now. We can similarly prove it, and the way to prove it is that you bring cot theta to the right side and try to show that cotec theta plus cosec theta is cot of theta over 2. It's an easy job. If once you bring in cos and sine, it should offer no difficulty. Then other we have got that sum of sine series when angles are in AP. So when angles are in AP, then we have got sine of alpha plus sine of alpha plus beta and sine of alpha plus n minus 1 beta. So notice that alpha plus beta and alpha plus n minus 1 beta, they are all in AP with common difference beta. And this, if you sum this series happens to be sine of n beta over 2 upon sine of beta over 2, and this is sine of alpha plus n minus 1 beta over 2. So this kind of thing it comes. And if you have the same series in cosine terms, that is cos of alpha plus alpha plus beta, and then cos of alpha plus n minus 1 beta, then sine n beta over 2 over sine beta over 2 remains the same, and sine gets replaced with cosine, and that is cos of alpha plus n minus 1 beta over 2. This term alpha plus n minus 1 beta over 2, you can also interpret as alpha plus n minus 1 beta over 2. That is, say, first term plus last upon 2, that argument. So first argument, I will say, so I will say first argument plus last argument and over 2. That's like AP. And the proof, of course, will come by multiplying this and then by sine beta by 2 each of the terms, and then telescopic series, and you will get this result. Let me do some problems which will use some results, some other results also. So first example that I take was asked in JEE Advanced. I will try to give the motivation also. Tan 70 degree is tan 20 degree plus 2 tan 50 degree. In fact, you could be given like this, that tan 70 degree minus tan 20 upon tan 50 equals what? So I will call them something like numerical identities. Numerical identities in which you are asked some angles are there, some numbers, and then you want to find some value. So of course, you want to find tan 70 minus tan 20 upon tan 50. Now, motivation should be that you have to find the relationship between angles. So try to find the relationship, suitable relationship between the angles involved, between the angles or between the arguments. So argument of tan is 70, or between the arguments involved, and use that relation to discover some identity. In this case, you have got 70 and 20. So 70 plus 20 is 90. So what I do, that suppose we have got angle alpha and beta such that alpha plus beta is 90 degree. If this is there, then I can write tan of alpha minus beta, their difference, by tangent formula, tan alpha minus tan beta, and 1 plus tan alpha times tan beta. I'm doing a general problem. So alpha and beta have got this relation. This is general. Now if this is 90, that means alpha is 90 minus beta. That means tan alpha is tan 90 minus beta. It is all degrees, 990. So this is cot of beta. And so I can say that tan alpha tan beta equal to 1. Means alpha plus beta is 90 degree, gives you tan alpha tan beta equal to 1, provided all are defined. Do not take alpha is say 90. Of course, it is not, it is meaningless. So alpha plus beta is 90 degree, means tan tan b equal to 1, tan alpha tan beta is equal to 1. And now, if this is so, then this relation implies now that tan of alpha minus beta equals tan of alpha minus tan of beta over 2. This goes something simple, 1 plus 1, 2. And so I can write that tan alpha minus tan beta is twice of tan alpha minus beta, provided, of course, alpha plus beta is 90 degree, this one. That tells you that you have got some kind of 70, 20, and 50. These numbers make sense because sum of them is 90, and this is just difference of them. So if I plug in 70 degree and 20 degree, you will get tan 70 degree minus tan 20 degree is 2 tan 50 degree. In fact, you can derive many more entities. Suppose you write alpha 70 and beta alpha say 70 already you have taken. So say we take alpha is 80 and beta of course then 10. Then we can write tan 80 minus tan 10 is 2 times 10, and their difference, that is 70 degree. So we can relate so many of things. Even we can relate these two also. You can eliminate tan 70 and we can relate these kind of things. So this all is really well, and we have got the identity. So I have generalized that for you. Next example again involves some tan, but a different result. So we want to find tan 6 degree, tan 66 degree, tan 42 degree, and tan 78 degree. Better I will write in order. So this value I want means I want tan 6, tan 42, tan 66, and tan 78. This value I want without, of course, tables. And anyway, you can't find these numbers. So the identity that comes to our mind is there is an identity like tan theta times tan of 60 plus theta times tan of 60 minus theta. That happens to be tan of 3 theta. We can derive it quickly that tan theta, suppose tan theta is t, so this is t. Tan 60 plus theta is tan 60 and plus tan theta, and upon 1 minus tan 60 tan theta. And similarly, tan 60 minus theta is tan 60 minus tan theta, and 1 plus tan 60 degree times tan theta. And if you do the work, you will get t times, this is root 3 plus t, and 1 minus root 3t, and this is root 3 minus t, and then you get 1 minus this one, 1 plus root 3t. So once we'll get t times, and you will get 3 minus t squared, and you will get here 1 minus 3t squared. So you are getting here perfectly all right that t minus 3t cube upon 1 minus 3t squared, and that is how tan 3 theta becomes. And so we will find that this is tan 3 theta. So if this is tan 3 theta, we should try to find which will take the role of theta here in this one. So suppose I take theta is 6 degree, theta is 6, then we get tan 6 and tan 66 and tan 54. That happens to be tan 18. So tan 6 is welcome, tan 66 is welcome. Tan 54 and tan 18, they are not welcome, because of course they don't figure in these numbers. So tan 6 has come, tan 66 has come. Let's focus how to get these numbers. Already 18 has come, so we have to get 18 again. So if you put theta 18, so we are doing two applications of it. This is tan 18, then tan 78, and then tan 42, and that becomes tan 3 times 18, that is tan 54. Now we are good because we have got now tan 78 here, and we also have got tan 42 here, that is tan 42. So these numbers also have come up. Tan for this, I will double tick it. So these numbers also have come up now. And whatever extra, if you multiply, they will cancel out nicely. So if I multiply these two, if I multiply, I'll get tan 6, this tan 18 and tan 18 and tan 54 and tan 54, they'll cancel away. I'll get tan 6, tan 42, tan 66, tan 78. I'll exactly get out to be 1. So that's a good question for integer type, where they can ask you that what, or some applications. Here we have done two applications. We have done two applications of this result, two applications. So that's wonderful that we got using like this. So these all come under the topic numerical identities. You are finding some numerical values. Then next we can take this one, that we want to find cosec 10 degree plus cosec 50 degree and minus cosec 70 degree. After writing once, I will keep writing cosec 10 to save space and time. And so this value you want. So I'll write this value p as 1 over sine 10 plus 1 over sine 50 minus 1 over sine 70. Obviously, there is no result like 1 by sine A minus 1 by sine B. So I take LCM, sine 10, sine 50, sine 70. And in the numerator, you have got first term is sine 50, sine 70, plus this is sine 10, sine 70, minus sine 10, sine 50. So these are the terms. Once you get that, look at this one, sine 10, sine 50, sine 70. We have got a similar result, which I will write here in background, and let me use the color green. So we have got one similar result, that sine theta, sine 60 minus theta, and sine 60 plus theta is 1 over 4 sine 3 theta. Let's check it. This is one line derivation based on another entity, sine A plus B. So if you recall that sine A plus B times sine A minus B is sine square A minus sine square B. Let's see what it gives. So applied to this result, sine of 60 plus theta, sine of 60 minus theta, that will be sine square 60 minus sine square theta, that is 3 over 4 minus sine square theta, and then sine theta times 3 by 4 minus sine square theta is 1 by 4. I can take common. This is sine theta, 3 minus 4 sine square theta. Take that sine theta inside, and you get 3 sine theta minus 4 sine cube theta. That's your sine 3 theta. So 1 over 4 times sine 3 theta. So that way we can use this result. Here we can take 10 to be, say, this one, theta is 10, then this nicely matters. So this becomes 1 by 4 times, and sine of this becomes 30, sine of 30, because you are putting here theta equal to 10 in this one. So this is 1 by 4 sine theta. This is no such luck. So I'll multiply by 2. So let's multiply by 2. And this is now 2 sine 50, sine 70, and 2 sine 10 sine 70 minus 2 sine 10 sine 50 and all those things. So let me change the color and simplify it. So when you simplify, so we are using 2 sine A sine B. So 2 sine A sine B is cos A minus B. So we are using 2 sine A sine B is cos of A minus B minus cos of A plus B. And so this is cos of difference of angle. So you get cos of 20 minus cos of 120 plus, apply it 3 times. So again, here we get cos of difference, that is, it is 10 and 70. So we'll get cos of 60 minus cos of 80 and negative. And this is cos of 40, negative sign is already there, cos of 40, and plus cos of 60. And upon this is 2 into 1 upon 4 and times sine 30, that is 1 over 2. So that becomes 2 simply. So we can write 2. So now we have got this answer as 4 times this number. So this cos 20, I just write cos 20, I don't know the value, minus cos 120, that's 1 over 2. Cos 60 is also there. So cos 60 is 1 over 2. I can say another cos 60, that is 1 over 2. And minus cos 80 and minus cos 40, that's what I'm getting. So 4 times this becomes 3 by 2. So this becomes 3 over 2 and plus. So 3 over 2 plus cos 20 minus cos 80 and minus cos 40. I will show you that this actually equals 0. That's trivial. So you just add the other two. So cos 20 minus cos C plus cos D apply here. So cos C plus cos D, so 2 cos C plus D over 2, their average. So that is 60 and difference over 2. So cos of 20. And then we are good because cos 20 minus 2 cos 60 is 1 over 2 and times cos 20. So that becomes 0. So indeed this number is 0. And so you got 4 into 3 over 2. And so 6 is your answer. That's a actually good answer for integer type. That we did. Strange that these are all numbers is presumably irrationals. Certainly they all give you this. When you do this kind of thing, you get 6. That's what attracts people, and that's what makes them beautiful, that you are getting the values of these identities without actually plugging in, just by some transformations. And moreover, you are happy when the answer happens to be rational. Lot of irrational numbers, and they give rise to some rational number. That's truly remarkable. Okay, continuing our journey, we this time a different thing. This power is more. So we want the value of tan 6 20 degree minus 33 tan 4 20 degree and plus 27 tan square 20 degree. I want this value. I want. When you see such kind of thing where they have got lot of powers, then best is that we can take just one thing, 10 20 some symbol. I can write this as, say, t. It means I want to 5 to the power 6 minus 33 t4 and 27 t square. That's my goal. That's I want. Now tan 20 I do not know, but I of course know tan 60. So the root is from 20 to go to 60. So we'll write that, okay, tan 60 is, this is t. So this is tan 60 is tan of 3. I will write theta, tan of 3 theta. So that is 3 tan theta minus tan cube theta over 1 minus 3 tan squared theta, that I used just 2 problems before. And then I have used tan theta t, so I can write 3t minus t cube upon 1 minus 3t squared. And this value I know. I do not know tan 20, but I know this kind of something which depends on tan 20, that equals root 3. But notice the powers. The powers are all 6. Another thing, here you have maximum cube. So motivation is to square. So 3t minus t cube is square, and that equals 3 times 1 minus 3t square whole square. So I get 9t square minus, this is 6t4 and plus t to the power 6, and this is 3 into 1 minus 6t square plus 9t4. So I'm getting 3 minus 18t square plus 27t4. Send everything to the other side. So if this is the case, then we are getting just good things, like we'll get like this, that this is t6. So we write t6 and minus 6t4, but there is 27. So t6 minus 33t4, then 9t squared, and here we had 18. So that will become this side 27t squared, and rest everything is constant, and 3 you leave this side equal to 3. So this is actually what you wanted. You wanted the value of, let me go back, you wanted t to the power 6 minus 33 t4 t6 t to the power 6 minus 33 t to the power 4 and plus 27t square. This value you wanted, and this value equals 3 if t is tan 20. So we got some numbers and we got our answer. So these are some numerical identities. Next is some relationship. Sometimes. So relationship between different quantities. As an example, we have got that x is given to be sine alpha plus sine beta, y is given to be cos alpha plus cos beta, and you have to find out tan alpha plus tan beta in terms of, obviously, in terms of x and y. In such situations, you should try to get as much information as you can from identities. So it is natural that I will use sine c plus sine d. So I rewrite x as sine c plus sine d, sine alpha plus sine of beta, that is 2 sine c plus d over 2, and cos of c minus d over 2. Similarly, I can write y is cos alpha plus cos of beta, and cos c plus cos d, that's 2 cos c plus d by 2 and cos c minus d over 2. And I can divide them because these two terms are appearing. So if I divide that, I'll get x over y is tan of alpha plus beta over 2. Of course, we are assuming that these things, cos alpha minus beta by 2 is not 0. That will be given when we give the values. We'll make sure it is for the paper setters to make sure that yes, this does not become 0. Your job is just to apply the correct identity by realizing these things, that they're of course given. Now x over y is tan of this one, but you want tan alpha plus tan beta. So right now we don't get this one, but I can write tan alpha as a background word, tan alpha plus tan beta, the quantity I want. I can write, if nothing good is there, I can write sine alpha by cos alpha and plus sine beta upon cos beta. So I get sine alpha cos beta plus cos alpha sine beta over cos alpha times cos beta. Now things look promising because sine A cos B plus cos A sine B, that equals sine of alpha plus beta, and cos alpha cos beta I can write in terms of alpha plus beta and alpha minus beta. That is, we will write 2 and 2 of cos alpha plus 2 cos 2 times cos of alpha cos of beta. So I can write 2 times cos of alpha, cos of beta. And we know that we can write this as 2 sine alpha plus beta, and 2 cos A cos B is cos of A plus B and plus cos of A minus B. So that tells you that we can write in this form. Now sine alpha plus beta I can get from here, because alpha plus beta by 2 to alpha I can climb by using this formula that we we are giving tan theta, and we want tan 2 theta. So we have got tan 2 theta is 2 tan theta upon 1 minus tan square theta. You have got sine 2 theta is 2 tan theta upon 1 plus tan square theta, and you have got cos 2 theta. Cos 2 theta is 1 minus tan square theta and upon 1 plus tan square theta. So these numbers you already have, and then we can use this expression. So already we can know alpha plus beta and this one, because they are half angles. Alpha plus beta by 2, that tan is known, that gives you this, and that also gives you this. Remaining is cos alpha minus beta. For that we do on a small thing again, that I can square and add them. If I square and add these relations, means x equal to sine alpha plus sine beta and y equal to cos alpha plus cos beta, square and add. That's a time honored trick. So square and add, you will get x squared plus y squared is sine alpha plus sine of beta whole square plus cos alpha plus cos of beta whole square. So if you expand, you will get sine square alpha plus 2 sine alpha sine beta plus sine square beta, and these terms will give you, I'll write just after it, cos square alpha plus 2 cos alpha cos beta plus cos square beta. When you add them up, when you add these two up, as you have to, you will get 1 plus 2 cos A cos A plus sine sine B, that is 2 cos A minus B, and plus 2 plus 1. So you'll get 2 times 1 plus cos of alpha minus beta. So you will get cos of alpha minus beta is x squared plus y squared by 2 minus 1. That is x squared plus y squared minus 2 by 2. So that's all right. Once we got these numbers, then I can calculate these things. So my answer is 2 sine alpha plus beta. So I can write 2 times sine alpha plus beta. That is 2 tan alpha plus beta over 2. And this is 1 plus tan square alpha plus beta over 2. That is sine alpha plus beta. Cos alpha plus beta is 1 minus tan square alpha plus beta by 2. And 1 plus tan square alpha plus beta by 2. And plus cos alpha minus beta, I already know from some technique. So 2 times, now this is 2, this is tan alpha plus beta by 2. So that is x over y. So that is x over y. And this is 1 plus x squared by y squared. And then you have got here 1 minus tan square alpha. So 1 minus x squared by y squared upon 1 plus x squared by y squared. And that equals here, this alpha minus beta by 2, that is also given, x square y square minus 2 by 2. If I arrange them, if I rewrite them, I get 4xy over x square plus y square numerator. In denominator, I get y squared minus x squared upon x squared plus y squared and plus x squared plus y squared minus 2 by 2. We can further simplify and we can get some answer. It depends on what form the answer is given. Or sometime in exam, suppose values of x and y are given. So sometime if values given, values of x and y, then you can put here now values and we can get your answer. So that was a long identity, long problem based on various things. So here first I divided one and then I squared them and then added both of them, and we got some other results from here. Okay, coming to the next one is 2 cos A plus 6 cos B plus 7 cos C plus 9 cos D equal to 0. and also given 2 sine A minus 6 sine B plus 7 sine C minus 9 sine D 0. This is given, and you want cos of A plus D over cos of B plus C. This you want, A plus D over B plus C. Let me rewrite this so that it looks better. And so you have cos of B plus C. Now, the motivation that I will give you is how to form cos of A plus D. For that, A plus D occurs here. So I can combine these two and combine these two just like previous example. So I'll rewrite it cos 2 cos A plus 9 cos D equals negative 6 cos B negative 7 cos C, and 2 sine A minus 9 sine D, that equals 6 sine B. This is cos B. So 6 sine B and minus 7 sine C. This is what we can rearrange. And if I square and add, this is D. If I square and add, so squaring you will get 4 times cos squared. So let me write 2 squared. So let me write this better as you will get 2 square cos square A, then 2AB, that is 36 cos A cos D, and plus 9 square cos square D is 6 square cos square B, and this is 84. So plus 84 cos B cos C and plus 7 square cos square C. We also have from second just cos replaced by sine, 2 square A sine square A minus 36 sine A sine D and plus 9 square sine square D. This is 6 square sine square B, and this is again negative of 84. So negative 84, and this becomes, this is positive by the way, negative 84. This is cos B sine C. So it is negative 84, and so negative 84 and sine B times sine C, and plus again 7 square sine square C. If I add these two, then I will get 2 squared because this is 1, and this is cos D minus sine A sine D. So I will get here 36 and cos of A plus D plus 9 squared, and here I will get 6 squared and 84. So I will get again 84 times, this is cos B cos C minus sine B sine C. I'll get cos of again B plus C, the expression that I want, and plus 7 squared. Now notice this strange thing, this happy thing. In this problem, 2 square plus 9 square is 6 square plus 7 square, because both are, this is 81 for 85, and this also is 36 and 49, that is 85. So they are both are equal. So these two together cancel out, they cancel out. And so yeah, I'm getting cos of A plus D. So I'm getting cos of A plus D over cos of B plus C is 84 over 36. And there is some common factor like 12. So 12, 3 and 12, 7. So I'll get the answer as 7 over 3. Notice how the sum of two squares was equal, and that made your life really simple, and you ended up with some good expression. In general, it is possible. You can put here anything PQRS. So I can put here PQRS, and I'll just make sure that because I'm adding P and R together and Q and S, so I will just make sure that P square plus R square is Q square plus S square. Then things cancel, and then I get my answer. In the next one is a problem that was asked in JEE mains, and of course it was asked maybe twice on many other exams also. So in triangle ABC, you have got 3 sine A plus 4 cos B equals 6, and 4 sine B plus 3 cos A is 1, then find angle C. Or maybe in multiple choice question, you can be asked more than one correct answer type, that how many values of C are possible. Then that would trap you, because this is a problem which requires some analysis. So what we do first, that again we use sum of squares. So it means you square and sum. So you do sum of squares for these two expressions. That will give you that 9 sine square A plus 24 sine A cos B and plus 16 cos square B equal to 36. And similarly, you will have here that 16 cos square B, which I write here, 16 sine square B here, 16 sine square B, and 9 cos square I write here. And here you have got again 24. So 24 sine B cos A equal to 1. Now when I add them, then I get 9 plus 16 plus 24 sine A sine B, and then you have got here sine B cos A. Sine A cos B cos A sine B. So that becomes 24 times sine of A plus B is 37. So 24 sine A plus B, that becomes 12. 37 minus 25. And so sine of A plus B, you get 12 over 24, that is 1 over 2. So I can write sine of C over 1 over 2. Now, the true point of question is that it is not given that C is acute or obtuse. This is not given. So it seems that we can have two answers. C is 150 degree or C is 30 degree, because angles of triangle, you will find out soon that this is not true. This 150 degree is not true. So we'll do it like this, that we'll say that we'll prove by something called contradiction, that if C equal to 150 degree, then in particular angle A, because a angle A is there, so C is 120, is all right. So we can say that C is, so let me erase it and then let me continue with one. So C has got two choices. So C is 30 degree. I write either, or of course 150. So I'll write clearly this is 150. Now, what is happening is that suppose C is 150, then you know that A is less than 30 degree, because together A plus B plus C has to make up 180 degree. So of course A alone cannot be 30, so A is less than 30. That is means that sine of A less than, because A is of course less than 30 and 0 to 30 it is increasing, sine A less than 1 over 2. If that is the case, then 3 sine A plus 4 cos B, which is given to be 1 over, which is given to be 6. So it is given to be 6. You will find that this is not possible. So if this is this, then 3 sine A plus 4 cos B less than 3 sine A, it is less than 1 over 2, and cos B maximum 1, so the plus 4 crude bound, that is enough to give the result. And this is 3 by 2 plus 4. Of course, this is less than 6. So 3 sine A plus 4b, you have found 4 cos b is less than 6 if you allow that A is less than 30 degree. This means C is 150. It means C cannot be 150, and so C must be 30 degree. So C is not 150, C has to be 30 degree. This requires really careful consideration, because it could be a good trap for multiple choice questions, more than one answer correct type, because there you really have to be on toes and think that how to eliminate them. Next is this one again, numerator, and it is root 3 cot 20 minus 4 cos 20 degree. You want this value, you want this is integer, so of course they make good choice for objective questions in or integer type. So I'll write this way, that this is most strange, cot 20 cos 20, but root 3 rings a bell in my memories. Root 3 means root 3 by 2 times 2, and this is something like sine 60 or cos 30, whatever you put it, root 3 by 2. So what I'll do, that I'll write root 3 cot 20, I'll play around like minus 4 cos 20 degree is, take out common, so take out 2 cot 220 common. You take 2 cot 220. Why 2? Because root 3 by 2 I want. So this is root 3 by 2. And so this is already out. And minus 2 sine 20 degree. That is your this thing. That is equal. Now 2 cot 20 you keep. Root 3 by 2, of course, I will write as sine 60. I'm not in cos 30 because I will apply sine c minus sine d. So I need sine 60. Sine 60 minus 2 sine 30, 2 sine 20 degree. So sine c minus 2 sine, let it be clear, 2 sine 20 degree. So I can write 2 cot 20 degree and times sine 60 degree minus sine 20 degree minus sine 20 degree. So 1 sine 20, I give it to cos sine 60, and apply sine c minus sine d. So this 2 cot 20 degree is carried. Sine c minus sine d is 2 sine c minus d by 2. Difference by 2, that is 20. And cos c plus d by 2, so sum by 2, that is average. So cos 40 and minus sine 20. So that is all right. This is good something. So sine 20 has now come out. So let me take it out. So 2 cot 20 and sine 20. And this is 2 cos 40 minus 1. Now 2 cot 20 cos 20 is nothing but 2 times cos of 20. And cos 40, I can write in terms of cos 20. So I can write 2 times cos 2 theta. I'm writing cos 2. I'm writing cos of 2 theta. So I'm writing cos of 2 theta is 2 cos squared theta minus 1. I want to prefer this form because everything is cos. So 2 times 2 cos square 40 minus 1 minus 1. So that is 2 cos 20. And this is 4 cos square 20 and minus 3. 2 minus 1, 3. Take this cos 20 inside. You will get 4 cos cube 20 degree minus 3 cos 20 degree. Now 4 cos cube theta minus 3 cos theta is cos 3 theta. So 2 times cos 3 theta. So 2 cos 60. And that is marvelous. You just get the result 2 times 1 over 2. That's 1. So they are really good for integer type. And you can never fail to appreciate that it really is exciting. And you must try to get the logic behind each of them. Let me now go to summation of series. So summation, or you say telescopic summation, because mostly they will cancel. That also is fairly common question in JEE. Now, to give you first example, that the method is this, that suppose I want to add up cosec theta, cosec 2 theta, and cosec 2 theta, cosec 3 theta, and so on to say n terms, or whatever, 10 terms, 20 terms, given theta also. So the result that I will use is these. So I will write the result in maybe red. So some results I'm using. So what I'm using, that if you have got something like cosec A, cosec B, cosec A, cosec B, then I will write this as cosec A minus B and cot B minus cot A. If I have got sec A, sec B, this kind of term, I can write as cosec A minus B times tan A minus tan B. And I can also write tan A, tan B type of term. Tan A, tan B type of term is cot of A minus B and tan of A minus tan of B and negate minus 1. All these are fairly easy to derive. So one derivation will be good. That you want cosec A, cos B. So you write cosec A, cosec B is 1 over sine A, sine B. Multiply with the difference. So write sine of A minus B upon sine A minus B. It's really important. And sine of A, sine of B. Sine of A minus B I will keep aside. Sine of A minus B. And this sine A minus B I can write as sine A cos B minus cos A sine B over sine A sine B. So now 1 upon sine of A minus B. Now sine A sine B. Sine A cos minus cosine B upon sine A sine B. Now sine A will get cancelled. So I can write this as cot of B minus cot of A. In telescopic series, let me tell you that if A minus B is constant for each term, for each summand or each term, then you can use that result and you will get a telescopic series. For example, let's similarly we can derive sec A sec B and tan A tan B. Let's derive cosec theta cosec 2 theta. Let's do it rather, cosec theta. So this is 1 by sine theta sine 2 theta cosec theta. So that is nothing but 1 upon sine theta, because difference 2 theta theta, 1 upon sine theta. And this is cot of B minus A. So we have assumed A minus B here. So cot of theta minus cot of 2 theta. In exam, you should not take much time to derive it. It should come to you very quickly. Sine 2 theta, sine 3 theta. Again, difference is theta. The theta here also difference is theta. So this is 1 upon sine theta. And then this is again cot of 2 theta minus cot of 3 theta. So it goes on like this, theta. Suppose I write the last term, nth term. So nth term will be sine n theta and sine n plus 1 theta. That is again 1 upon sine theta, because argument is still, its difference is constant, theta. And this you are getting as cot n theta minus cot of n plus 1 theta. When you add of them, add them, then telescopic cancellation occurs, and so cot 2 theta cancels with this one, cot theta. 3 theta must have cancelled from somewhere, and cot 10 theta cancels with here. So you are left with that this series the series is 1 by sine theta time cot theta minus cot of n plus 1 theta. This is how you get your answer, and that's very easy, because once you get that, you can always plug in that. We can take one other example that is slightly tricky. So we have got sin x upon cos 3x plus sin 3x upon cos 9x, sin 9x upon cos 27x, and that equals 1 over 2. Prove this, tan 27x minus tan of x. This is there. Now again, see, this is 13927 looks like GP. So we have to form in some suitable manner and simplify. So what we can write, that sin x by cos 3x, one term let's us play with. I can write every term similarly, in similar manner. So sin x by cos 3x I will write as 1 upon, I'll start with multiplying cos x in the numerator and denominator. So cos x cos 3x in the denominator first, and numerator cos x sin x. And then you can write 2 also, because 2 will cancel. So 2 cos x sin x is nothing but sin 2x, and upon 2 cos x cos 3x, so I can write here 2 times cos x cos 3x. I can write sine of 3x minus x upon 2 cos x cos 3x. So that will give you sine 3x cos x sin x cos 3x upon cos x cos 3x 1 over 2. So 1 over 2, and this becomes your tan of is tan 3x. So that is tan 3x minus tan of x. So far so good. So let's write what we got, sin x upon cos of 3x, that equals half tan over 3x minus tan of x. The next term is 3x and 9x. So replace x with 3x, you get sine 3x over cos 9x is half of, and you get tan 9x minus tan 3x. Again, replace x by 3x, sine 9x. So this is like sine 9x. You get sine 9x over cos 27x is half times tan of 27x minus tan 9x. If you add them up, then you will get sin x upon cos 3x, sin 3x by cos 9x, and sin 9x upon cos 3x. That is half of tan 27x minus tan 9x. That tan 27x minus tan of x you will get. So that is your answer for this. We also have some application in finding greatest value. So we will say greatest least values application. Greatest least values. So suppose you have to find f of x equal to sin square x plus cos to the power 4x, and of course x element of R. You want to find greatest least values. These questions, in fact, can be reduced to either quadratic or linear or some other results which we can deal. So let me write fx as g of t, that is t plus 1 minus t squared, where t is sin square x. I can assume. So this is t element of 0 to 1 closed both. So finding the least or greatest of fx on x element of R. So fx on x element of R is equivalent to gt on t element of 0 to 1. They are the same question. So now gt is quadratic. So let me arrange this. This is t square minus 2t plus 1 plus t. That is t square minus t plus 1. So I want this quadratic. Now this quadratic is t square minus t plus 1. For this discriminant is negative. So it goes like this. And this is t equal to 1 by 2. And 1 by 2, this height, at 1 by 2, if you this height, that is minus d over 4a. So minus 3 by 4. So that is 3 over 4. So that is 3 over 4. And here you have got somewhere 0 and somewhere you have got 1. So you want in this region, I will just color it. You want in this region. So you want this region 0 to 1, greatest least value. So you know that g of half will give you minimum, and g of half is 3 over 4, and g of 1 or g of 0, anyone, because both are equally spaced from half. So g of 1 or g of 0, I will calculate g of 0. So g of 0 is just 1. So you will get this as greatest value. So range of expression that becomes 3 over 4 and 2 1. Let's take another example, that f of x is 1 over 3 sin x plus 4 cos x plus 2. Again, let me write 3 sin x plus 4 cos x equal to t. Then I know that t belongs to minus 5 to 5, because we know that a sin x plus b cos x mod less than or equal to root of a square plus b square. So now I get this gt as 1 by t plus 2. And of course, t is not minus 2, which is an element here. So I just draw a curve. Say this is u. So draw the curve in t and u. So this line is t equal to minus 2, t equal to minus 2. And then say I draw a graph here this way, and once I have this graph, so I will draw like this, and I will draw one here, one this kind of thing, and t equal to 5. So t equal to 5 is here, minus 5 is here, t equal to minus 5 is here. At minus 5, this value, this height, has to be 1 upon minus 3, so that is 1 upon minus 3. At 5, this is 1 over 7. It is plus infinity, it is negative infinity, plus infinity. So the graph is strictly decreasing in each of interval. So we got minus infinity to minus 1 over 3, that is taken, and then union we are getting 1 by 7 to infinity. And so that is your range of the given expression of 3 sin is 4 cos x. And so that answers our question. Okay, so I'll stop sharing now. It's time to go. Okay, so that's all for today. Let's meet